Okay children, so let us try to understand the law of conservation of momentum more clearly with respect to few examples. So we know you have already familiar with this example, that is recoil of a gun, which we have already tried to explain in the Newton's third law of motion. Well, so for this what we consider is the gun bullet system. So initially, if you consider a gun inside which a bullet is there, so initially this bullet inside the gun both are under rest condition. Okay, gun along with the bullet. Okay children, so gun bullet system. So this bullet, when it was inside the gun, okay, let us consider it as a system. So initially this system is at rest. The system indicates two things. One is bullet, the other is gun. Okay, when it was fired, we know that the bullet moves forward. So in order to conserve the law of conservation of momentum, in order to conserve the momentum, as the bullet moves forward according to Newton's third law, to conserve the momentum, as there is no net external forces acting on the system, only bullet and gun forms the system, no other external forces acting, just bullet is being fired up. So in order to conserve this momentum, what happens? This gun gives a backward jerk, okay, to maintain the law of conservation of momentum. Is that clear children? Well, in order to, let us try to find out the recoil velocity of the gun. So initially, let us suppose that, okay, the initial velocity of the bullet be some u and the mass of the bullet be some m. Okay, so let us suppose the mass of the bullet be mb and initial velocity of the bullet be ub. Similarly, let us also suppose the mass of the gun be mg and initial velocity of the gun be ug. Okay, when the bullet is being fired, okay, what happens means this gun mass of the gun again remains same, that is mg. Well, whereas the bullet moves forward with some velocity, let the velocity of the bullet be some Vb and mass of the bullet is as usual, that is mb. Mass of the bullet before firing and after firing is mb and mass of the gun before firing and after firing remains same, that is mg. Whereas the initial velocity of the gun is uz, initial velocity of the bullet is ub, final velocity of the bullet be vb and final velocity of the gun be vg. Okay, according to law of conservation of momentum before firing, the total momentum before firing, because this gun is at rest condition, even the bullet is also at rest condition before firing, the initial velocities of the system before firing is 0. Then what we observe was the total momentum before firing is found to be mg ug plus mb ub. This how much children? This is 0 plus 0. Finally it is the total momentum is found to be 0. After firing, it was found that the total momentum of the gun is mg vg and the momentum of the bullet is mb vb and the total momentum of the system, that is gun and bullet after firing, is mg vg plus mb vb, whereas before firing the total initial momentum is 0. But according to Newton's third law, this total momentum before collision must be equal and opposite to the total momentum after firing. That means, what is the total momentum before firing children? 0 must be equal and opposite to the total momentum after firing. So this implies 0 is equals to minus mgvg, minus take it inside, then we have minus of small mbvb. This is bullet and this is gun. Okay children? Well, so let us bring this minus the other side, then this will become mgvg is equals to minus of mbvb. Or the velocity of the gun, the final velocity of the gun is found to be minus of bullet mass upon gun mass into velocity of the bullet. The ratio of the two masses multiplied by the velocity, the speed of the bullet in the opposite direction. This minus indicates that as the bullet moves forward, the gun will give a backward jerk. And with what velocity would the gun will move with the in the backward direction is the velocity of the gun in the backward direction is given by mb by mg. So mass of the bullet to the mass of the gun ratios in multiplied by speed of the bullet. Is that clear children? Well, so this is an important relation you need to remember children. Okay, well, so this was the example. So whenever the bullet is being fired, the bullet goes forward, whereas the gun gives a backward jerk in order to maintain the law of conservation of momentum, because the gun and bullet together forms a system and here no other external force acts on it. Similarly, the same thing can be explained during the movement of a rocket in upward direction. So children, if you consider, if you observe a rocket, okay, so inside a rocket the fuel is being burnt, and whenever this fuel is being burnt, the gases will eject outwards with large velocity. When the fuel is burnt, the gases come out with large velocity. According to law of conservation of momentum, as no net external forces acting on that, so in order to maintain this conservation, as the gases are coming out with high velocity in the backward direction, as a result, to maintain the conservation of momentum, this rocket will move up in the opposite direction. Gases will be coming downwards, whereas rocket will be moving upwards. This is all according to the law of conservation of momentum. The same can be explained for an inflated balloon. Children, if you observe any balloon, okay, so inflated balloon means the balloon that is blown fully, okay, and if you simply pierce it, okay, this balloon is simply pinning, okay, a small hole is being cut. This, let us suppose that this balloon is simply lying on the floor, now it is in rest condition. Now if you pierce the balloon by the help of a small pin, okay, then what happens? A hole is being observed. Because of that hole, from that hole, what happens when you pierce it? The air will comes out with large speed. When the air comes out with a large speed, as a result, in order to maintain the law of conservation of momentum, the balloon, that inflated balloon, moves forward. Air comes backward in the opposite direction, the balloon moves forward. This is also according to the law of conservation of momentum. And one more example, children, if you observe the man and the boat. So whenever the boat has reached the bank of a river or something, then whenever a man inside the boat, okay, this is the bank of the river, okay, so whenever this person jumps out of the boat, so the person moves out of the boat. In this case, in order to according to the law of conservation of momentum, for every action, Newton's third law, whatever you observe, so this happens, the body moves forward. Initially both are in rest condition. As the man moves forward, in order to conserve the momentum concept, the boat will give a backward jerk. As the man moves forward, as a result, result, the boat will move a little backward. So this is all according to the law of conservation of momentum. So all the examples which we have discussed, there is no net external force acting on the system. So the that means the total momentum remains constant as no external force acts on it. In order to conserve this total momentum, so what happens, as either the gases, air, man or bullet moves forward, according to the total law of conservation of momentum. So momentum before and after the scenario must be remain same. So as a result, other part will move a bit backwards. Okay children.